Welcome to this video on the structure of the atom. Atomic theory has come a long way since ancient Greeks like Democritus first proposed the idea of indivisible particles. In this video, we'll explore the milestones that have led us to our current understanding of the atom's structure. Let's dive in. The ancient Greeks had a fascinating and intuitive understanding of atomic structure, which was based on their philosophical and scientific observations. While they did not have the benefit of modern scientific tools and techniques, they made some remarkable contributions to our understanding of the atom. In the 5th century BC, Democritus, a Greek philosopher, proposed the concept of atomism. He believed that everything in the universe is composed of indivisible particles called atoms, which are eternal and indestructible. Democritus thought that atoms are indivisible, infinite in number, and can combine in various ways to form different substances. Democritus' atomic theory was based on the following principles. Atoms have always existed and will always exist. Atoms cannot be divided into smaller particles. There are an infinite number of atoms. Atoms can combine to form different substances, such as water, air, and earth. The properties of substances, such as color, smell, and texture, are determined by the arrangement of atoms. Pericles, a Greek philosopher and student of Democritus, made some significant contributions to the development of atomic theory. He proposed that atoms are not only eternal but also have inherent properties, such as shape, size, and weight. In the 3rd century BC, Epicurus, a Greek philosopher and student of Democritus, developed further ideas on atomic theory. He believed that atoms are not just eternal but also have a natural tendency to move and combine in different ways. Epicurus also proposed that atoms have inherent properties, such as weight and shape, which determine their behavior. The ancient Greeks' understanding of atomic structure was remarkably similar to modern atomic theory. They envisioned a universe composed of tiny, indivisible particles, atoms, that combine in various ways to form different substances. While they did not have the tools to observe or manipulate atoms directly, their philosophical and scientific insights laid the foundation for later scientific discoveries. John Dalton, an English chemist and physicist, proposed several key concepts about atomic structure in the early 19th century. His work built upon the ideas of earlier scientists, such as Antoine Lavoisier and Joseph Priestley, and laid the foundation for modern atomic theory. Dalton proposed that elements are composed of tiny, indivisible particles called atoms, which cannot be created or destroyed. He suggested that atoms are made up of smaller particles called corpuscles, now known as electrons and protons, which are arranged in a specific way. Dalton proposed that each element has a unique set of atoms with specific properties, such as mass and volume. He introduced the concept of atomic mass, which is the total mass of all the particles in an atom. Dalton proposed that the atomic weight of an element is the average mass of its atoms, calculated by dividing the mass of a sample by the number of atoms it contains. He suggested that the proportions of atoms in a compound are fixed and cannot be changed. Dalton proposed that when two elements combine to form a compound, they do so in a fixed ratio by mass. He suggested that when two elements form multiple compounds, the ratios of their masses are always simple multiples of each other. Dalton's proposals about atomic structure were groundbreaking and paved the way for further research in the field. His work laid the foundation for modern atomic theory, including the discovery of subatomic particles like electrons and protons. J.J. Thomson, a Scottish physicist, made significant contributions to the understanding of atomic structure. His work, published in the late 19th and early 20th centuries, built upon the foundation laid by earlier scientists like John Dalton and John Strutt, Lord Rayleigh. In 1897, Thomson proposed the plum pudding model, where atoms are composed of a positively charged sphere, the pudding, with negatively charged particles, the plums, embedded within it. This model was an attempt to explain the behavior of cathode rays. Thomson discovered the electron in 1897 while studying the properties of cathode rays. He proposed that these rays were composed of tiny, negatively charged particles, which he called corpuscles, now known as electrons. Thomson suggested that the electrons in an atom are not localized at specific points, but are instead distributed throughout the atom in a cloud-like manner. He proposed that atoms consist of a positively charged nucleus surrounded by a cloud of electrons. Thomson's work led to the development of the nuclear model, where the nucleus is composed of protons and neutrons and is surrounded by electrons. Thomson calculated the ratio of the mass of an electron to the mass of an atom, which was approximately 1 to 1836. Thomson's work laid the foundation for further research in atomic physics, including the discovery of subatomic particles like protons and neutrons by Ernest Rutherford and James Chadwick. Ernest Rutherford, a New Zealand-born British physicist, made significant contributions to our understanding of atomic structure. His work, published in the early 20th century, built upon the foundations laid by earlier scientists like J.J. Thomson and Lord Rayleigh. In 1911, Rutherford proposed the nuclear model, where the nucleus of an atom is composed of positively charged particles, protons, and neutral particles, neutrons. This model revolutionized our understanding of atomic structure. Rutherford demonstrated that atoms have a central nucleus, which is surrounded by electrons. He showed that the nucleus is extremely dense and has a very small radius compared to the atom as a whole. Rutherford proposed that the nucleus of an atom is composed of protons and neutrons, which are collectively known as nucleons. He showed that the number of protons in an atom's nucleus determines its chemical properties. Rutherford introduced the concept of mass number, which is the total number of protons and neutrons in an atom's nucleus. This concept is essential for understanding nuclear reactions and radioactivity. Rutherford defined the atomic number as the number of protons in an atom's nucleus, which determines its chemical properties. Rutherford proposed that certain combinations of protons and neutrons in an atom's nucleus are stable, while others are unstable and may undergo radioactive decay. Rutherford discovered alpha, beta, and gamma radiation, which are forms of ionizing radiation that can be emitted by atomic nuclei. Niels Bohr, a Danish physicist, made significant contributions to our understanding of atomic structure. His work, published in the early 20th century, built upon the foundations laid by earlier scientists like Ernest Rutherford and J.J. Thomson. In 1913, Bohr proposed the Bohr model of the atom, which is a quantum mechanical explanation of atomic structure. According to this model, electrons occupy specific energy levels or shells around the nucleus, and they can jump from one energy level to another by emitting or absorbing energy. Bohr proposed that electrons occupy specific energy levels or shells around the nucleus, which are determined by the energy required to remove an electron from the atom. These energy levels are quantized, meaning that they can only have specific discrete values. Bohr proposed that electrons have an intrinsic spin, which is a fundamental property of particles like electrons. This spin is responsible for the magnetic moments of atoms. Bohr's model introduced the concept of quantization of energy, which states that energy is not continuous, but rather comes in discrete packets or quanta. This idea is central to quantum mechanics. Bohr proposed that electrons occupy stationary states, which are specific energy levels around the nucleus where electrons remain until they are excited or ionized. Bohr's model predicted that when an electron jumps from one energy level to another, it emits or absorbs energy in the form of photons, which correspond to specific wavelengths of light. This led to the prediction of spectral lines, which are observed in atomic spectra. Bohr's model introduced the concept of a quantum leap, where an electron jumps from one energy level to another by emitting or absorbing a photon. And that's a brief overview of the milestones in atomic theory. From ancient Greece to modern times, scientists have worked tirelessly to uncover the secrets of the atom. Today, we have a comprehensive understanding of the atomic structure, but there's still much to be discovered. Thanks for watching. If you enjoyed this video, please subscribe to our channel for more science content. And don't forget to like and comment below.